distance gets bigger, the force isn't as big.
Excellent. Okay, well today we're going to talk about another aspect of what's called Coulomb's law, which is what we've been studying. And we're going to talk about how the amount of charge between each particle can change the force that's between them. So the first thing that you guys are going to do is you're going to do an inquiry activity using an online simulation and answer some questions about what you guys think can work together as a team. Here's your worksheet. Do you guys want just the computer, or do you want it on the big screen?
Still on the big screen.
Yeah, everything's cool, it's bigger, right?
There it is. Okay. And run the applet file online. Then we're supposed to move them around.
Yep, so first spend a couple minutes not doing the, don't quite start on the worksheet right now. First spend a couple minutes just kind of exploring what happens and doing some things, and then we'll take a look at the worksheet.
So we just move around.
Yep.
So F stands for force, I'm guessing.
Force. Is that right?
Mm-hmm.
When they're close, the force gets bigger.
You can also change the charge at the bottom with that slider on the left.
This one?
Yep.
That's a fat charge.
And you can change the green one too by using that drop down menu.
Can you change the, so they're the same?
Yeah, you just move the slider, right?
That just makes it bigger.
Oh, so there's sliders,
I mean,
so they're the same.
So they're the same charge, though.
Oh, but right now green Q's at 1. And this red Q all the way down to 1. Yeah, they're the same charge. Get out of the third one too.
Well, I mean, opposite.
Oh, so it's like a negative? Can we make it negative?
I don't think so.
Not this. You think it? No, I think that's just an indicator.
So if we make the one,
I wonder if we can't drag the red one.
I think it's just a minor glitch. I think you can. You just have to get the right.
The right spot.
There it is.
Like the exact center.
Yeah.
So now the church is bigger, like even bigger than when they were both small.
Mm-hmm.
So we added more charge. The force got bigger too.
That's a great hypothesis. So with that hypothesis, why don't you guys start on going through the steps on the worksheet and answering the questions and working through them?
Okay.
what happens if the force is, each force particle is the same charge as charge?
They have the same because they're repelling. Reset it. How does the force on the red charge compare to the force on the green charge? Wait, same force. Now use the red slider, change the charge on the red charge.
Force stays the same.
So they both get bigger at the same rate. Sketch your configuration below and record the force on each particle. That's it right there. So green on the top, the red on the bottom. Force is 24.7 force units. Yay, you did it! Is there more?
Oh, sorry.
Yep, it
Yeah.
is on that page. What
Yeah.
experiences the larger force? That's a trick question. It's the
students find it surprising, think back to use their law usage to explain because they interact with each other so they have to exert the same force.
So I think it's like Newton's third law, that's the equal and opposite one. So if red exerts a force on green, green exerts the same force on red.
Excellent, Jenny.
Oh.
No cell phones in class.
What's that?
No cell phones in class.
Set the red back to Q equals 1. If you change set to green, try what you expect will happen. Why? Try to take it. It'll be the same thing.
Yeah, so green's gonna get bigger, but their force are both gonna increase.
You sure?
Yeah.
Let's try.
Watch out the big screen. Good call there.
Good work. It's blue red. Because it's the same clockwise.
Yeah.
You actually observers still described by Combs force law instead of Combs force is given by F equals K Q1 Q2 are squared. K is constants. Just R and Q and Q1 Q2 are the charges. The two particle and R is the distance between the two particles. Explain how this matches what you observed.
So if we increase charge, the right side of the equation goes up. So to keep it equal to the left side of the equation has to go up, which is force. And if we increase R, that changes the distance. So if they get further apart, the force goes down. And yeah, it's the same thing.
How much do you think it goes down? Does it, if you increase the distance to 2 from 1, do you have to decrease the force to 1/2? How does it change?
It goes down to 1/4.
Why?
Because it's squared off the bottom.
It's the inverse square law that Mr. Howard taught us before.
Hmm?
It works for magnets too. What is the direction of the ground force? It's away,
Each other.
away from each other.
Because of the same charge.
But if we had a negative charge, then it'd be a negative sign up on here, so force would have to be negative, which means it would flip around and point the other way.
Okay, so why don't you guys summarize for me what you learned from the activity about Coulomb's law?
Maybe like,
Now, Coulomb's law.
Mm-hmm.
What we learned that as you increase the charge on the particle, the force will increase between two particles will stay the same because it's Newton's third law. So it just gets bigger. And if you switch particles, it's the same thing. And as you move them in and out, closer and further away, it's basically, it does the same thing almost as making doing one charge, makes the force bigger or smaller, depending on whether or not you add charge or take charge away.
Okay. What happens if the distance changes?
If the distance changes,
Mhm.
it follows the inverse square law. So if it gets closer, it gets bigger. The force gets bigger. If they get further away, the force goes down.
Great.
Just like that.
All right, so we're gonna now we're gonna move into a peer tutoring activity where you guys are gonna work through some problems and kind of figure out how the concept applies a little bit more with numbers. So I'm gonna pull up those questions now.
What is
So you guys have already answered that question, so we'll make you guys answer it again, but
So do you mean you want like So on the test, is that like the equation of Coulomb's law, or just the concept of what happens?
Both.
Both.
Yep.
So explain how force changes when charge increases.
You are popular.
Explain how force changes when charge increases. So when the charge increases, the force increases.
Yes.
Because yeah.
Because more charge means like there's more stuff to repel or attract. Yeah.
Describe the types of charges that repel and attract. What was that? I don't remember.
You haven't learned it yet. I'm gonna teach you next.
Oh.
Yeah.
2-point charges are 3 or only charges 0.5 millimeters.
I'm gonna need paper for that.
What is the force?
We can do it on the whiteboard.
Oh, okay.
0.2 times 0.5 is 0.1 times K over.
Oh, yeah. So R equals 3, Q1 equals 0.5, Q2 equals 0.2. That is the force between them. Like ignore K.
Yeah, you can ignore K because it's just a constant.
So they have 1 times 0.5 plus 0.2 all over 3 squared. So 0.5 times 0.2, 0.1. Isn't it 0.01? Maybe it's 0.01. White 1 over 9. That's the other way.
No, it's 0.01.
Yeah?
Yeah. 0.01.
Okay.
So
So
that's
that's
the
the
force.
force in Newton.
So do you guys
K is 1.
think that that's a really strong force or a weak force?
It's weak because it's little less than 1.
Alright, so here's another question for you guys. If the radius, or sorry, if the charge of Q1 is now 3, and the charge of Q2 is 4.5, and the force is 10 newtons, what's the radius?